Hey everyone, and welcome to This Explainer. Today is honestly a massive day. We are officially leaving that super comfortable world of drag and drop programming behind, and we're stepping into the real deal, text-based coding. If you've been using tools like Scratch, you've already built up some pretty incredible logic skills. Now we're going to unlock a whole new level of power by learning to write our very first text-based programs in Python. I am so excited to guide you through this transition. So get your keyboards ready, and let's get coding.
But before we actually start typing anything, let me hit you with a weird question. What happens if you try to add your age to your name in Python? Like, what exactly is 11 plus Sarah? I mean, it sounds completely bizarre, right? Well, it turns out computers get extremely confused by this too. If they don't know exactly what kind of information or data they're looking at, they literally just throw their hands up and crash. Understanding how a computer looks at different kinds of information is going to be our absolute secret weapon today.
Okay, section 1, blocks to text. Let's get right into it.
So let's talk about the big change here. You're probably used to block-based coding, right? Places like Scratch, where you drag and drop these ready-made blocks that just click together like digital Lego bricks. You never really have to memorize the exact code. But now we're stepping into text-based coding with Python. And here you type every single instruction yourself. That means you're taking on a new responsibility. You actually have to remember the correct spelling and grammar of the code, which programmers call syntax. It definitely takes a little more practice, but the trade-off? It is so much more powerful.
But notice how perfectly the old connects to the new. A green when run block and a blue say hi block from Scratch map directly to just typing print hi in our new text editor, which we call an IDE. I really want you to remember this. The big ideas, things like sequences and making decisions, they are exactly the same in both. You already know how to code. You're literally just learning a new language to express those exact same ideas.
Oh, and a super quick fun fact for you. When you hear the word Python, you probably picture a giant, scary snake, right? Well, surprisingly, the programming language Python wasn't named after the reptile at all. The creator of Python actually named it after a classic British comedy television show called Monty Python's Flying Circus. He wanted the language to feel fun, a little mysterious, and just really enjoyable to use. So, no snakes involved, just a great sense of humor.
All right, section 2. Meet the data types and variables. Let's build our foundation.
Imagine you're moving to a new house, and you have this huge cardboard box. What do you do so you don't lose your favorite stuff? You write a name on the outside of the box with a marker, like toys or books, and then you put your things inside it. Well, that is exactly what a variable is in Python. It's basically just a named storage box inside the computer's memory. We give the box a name and we keep important values in it so our program can remember them while it's actually running.
And those handy storage boxes help us with the 3 essential steps that make up almost every single computer program in the world. Step 1 is input. That's the data the user types into the keyboard. Step 2 is the variable. That's where our program grabs that input and stores it safely in our labeled box. And finally, step 3 is output. That's when the program takes what it's stored, maybe does a little magic with it, and shows a result back to the user on their screen.
So putting that all together, you have your input command reaching out to the user to get information. Then that information flows right into our variable, where we say name equals whatever they typed. Finally, that flows to the print command, which outputs our greeting back to the screen. Input, variable, output. It's totally the heartbeat of programming.
But hold on a second. What exactly are we storing in those boxes? Just like you wouldn't store a messy, greasy slice of pizza in the same box as your clean library books, Python needs to organize its information into different data types. Here are the big 3 you absolutely need to know. First up, the integer. This is a clean, whole number, like 1, 2, 3, 8, or even -3. 0 decimals allowed. Next, we have the real number, which programmers usually call a float. These are numbers that do have a decimal point, like 1.5 or 3.5. And finally, we have the string. A string is just text, but here is the golden rule. Strings must always wear a disguise. They have to be wrapped inside speech marks, like A or the word DACA. If it has speech marks, Python treats it as text.
Moving right along to section 3, the Python calculator. Let's do some math.
Python is honestly one of the most powerful calculators on the planet, but it uses specific symbols on your keyboard to do the math, which we call operators. Addition and subtraction are super easy. They just use the standard plus and minus signs.
but look a bit closer at multiplication and division. Because we don't really have a traditional multiplication X sign on a keyboard that works for math, Python uses the asterisk symbol, which is usually Shift plus 8, and for division, we use the /. All right, it is your turn. I want you to play computer for a second. Check out this simple program. We have a variable x storing the number 12. We have a variable y storing the number 3. Then we create a variable called result that equals x divided by y. And finally, we print the result. So, what exactly is going to pop up on the screen? Take a guess.
If you guessed 4, you are so incredibly close, but the actual output is 4.0. So the crucial point to remember here is this. Whenever you divide in Python, even if it divides perfectly evenly, like 12 divided by 3, Python always gives you back a real number, or a float, with a decimal point. It's a tiny little detail, but honestly, it's exactly the kind of thing that makes you a really smart programmer.
Okay, Section 4, the input string trap. Listen closely, because this is the #1 thing that trips up new coders. Remember our input command from earlier? The one that asks the user to type something? Well, it has a secret. Whenever a user types anything into an input box, even if they type the number 5, Python automatically slaps speech marks around it and treats it as a text string. It literally sees the word 5, not the math number 5. And remember my weird question at the very beginning of this explainer? You can't do math on text.
So let's look at this trap in action. If you just write age equals input and the user types 12, Python sees the text 12. If you try to add 5 to that, boom, the program crashes. But look at the solution. We have this superpower called casting. What we do is wrap our input command inside int. This stands for integer. By typing age equals int input, we're forcefully telling Python, hey, take whatever text the user just typed, rip off those speech marks, and turn it into a real, whole math number.
Let's walk step by step through a worked example to really see our casting hero save the day. First line, a equals int 5. Python takes the text 5, strips away the quotes, and stores the actual math integer 5 in variable a. Next line, b equals int 4. Same exact thing. It stores the integer 4 in variable b. Next up, total equals a times b. Now Python can confidently do the math. 5 times 4 equals 20. And finally, it prints out answer, 20. Because we used int, the whole calculation worked flawlessly.
And that brings us to our final section. Section 5, your turn to code. You now have the fundamental tools you need to build real software.
You understand variables, you get data types, operators, and you know how to cast text into integers. So, I'm going to leave you with a final challenge to prove your new coding superpowers. Can you go to your IDE right now and write a program that asks the user to type in a number, uses casting to turn it into an integer, multiplies it by 2 to double it, and then prints that result back to them? I know for sure you can do this. Get out there, start typing your syntax, and watch your code come to life. Thanks so much for joining me on this explainer, and happy coding.